we're in Burback National Park at the moment. We're just in the swamp forest. We've walked along the boardwalk into the forest. Yeah. So the peat is pretty deep here. I think it's 5 meters. So as you go into the forest, the peat starts to dome, forms a natural dome here. So here we've got quite a lot of peat. It's good deep peat here. Here we have the peat. It's essentially organic matter that hasn't been able to decompose, because here we can see the water table is so high. Now oxygen can't get in, so basically that means that this organic matter builds up, it becomes, let's say, super concentrated. It holds so much carbon. What we want to know is what happens if we drain this peat, take it out of its natural context. What's going on? So for me, I'm looking at methane and nitrous oxide. Nitrous oxide, it holds 300 times more heat than carbon dioxide. So we need to find out what processes are happening to create these fluxes. And my other plot is a palm oil plot. Now, initially the palm oil plot would have been this. It's on peat, on deep peat, the same, and it's been deforested. Now, to grow palm oil, they've had to drain the peat. Now, I want to understand if this process is affecting production of nitrous oxide and methane. And when you change a habitat, different animals move in, you get a whole different biodiversity. So I want to know how this affects gas flux. So here, this is my baseline. This is the original, let's say. Nitrous oxide is basically composed of nitrogen, but they apply fertilizer in palm oil. Now you take away all the water, you apply more nitrogen. Now is this a reason that more greenhouse gases can be given off from palm oil? This is one of my sample plots. I'm just putting on the hood. Now what that's doing is, over half an hour, if I can get it on, in half an hour the gases from the peat are going to accumulate inside here. So every 10 minutes I'm going to take samples from this plot. So I'm attaching the vial. This vial's actually vacuumed. So what I'm going to do now is I'm going to create a vacuum inside this bit because it's full of air, and then take samples. Now at the moment it's just atmospheric, the atmospheric sample. So I'll make sure we're all closed. On my barometer I can check if I have evacuated it. Yeah, I have. So I'm going to let some of the chamber gas in. Just draw some out. Now this basically flushes through the tubes, so if I do take any sample, it's there. Now I'm going to re-evacuate my tubes, so I create a vacuum which draws the gas into my vial. So now I open this, release the gas into the vial. I close this now, I close my vial, and that's my first sample taken. I will come back in 10 minutes and do exactly the same again up until half an hour. This gas sample now, it will be put through a GC in our lab at Jambi. Now what that's going to measure is methane and nitrous oxide, the concentrations in the air, parts per million, and also from that we can work out how much gas is emitted per metre squared, and then we can scale it up to hectares as well. This is really good because then with a given area we can take averages from this data, and we'll also match it to data that's already been collected, and we can see, compare, contrast, see what's going on and try to look at what's going on in the peat. So here we've got a piezo. Now what this is basically a 2-meter pipe that's driven into the ground. Now the water table inside, we'll be able to measure how high it is. This is important because I want to find out how the water table level affects the gas fluxes. So we're just in the older palm oil plantation. We're heading to the CIFOR plot. We're now in CIFOR's little research plot in the palm oil plantations at SMP near Jambi. The palms here are 7 years old now. They're just coming up to 7 years old. They're on peat. So what we've got here is we've got about 3 or 4 rows of these palms, and each of us has got a different research schedule set up. Large scale, this palm oil plantation is vast. The area of peat that it's on is vast. Now, if this process scaled up is happening across the tropics, you know, on a global scale, this is actually going to have a really big impact on global warming.